All right, let's dive in. Today, we are going to tackle one of those classic GCSE maths questions that can really feel tricky, the geometry proof. But don't worry, we're going to break this one down step by step so you can see exactly how to lock in those full marks. Let's get to it. Ever see a question that starts with prove that, and your mind just kind of goes blank? Yeah, you are not alone. These questions are a bit different, right? They're not about finding a number, they're about building a watertight logical argument. And honestly, once you get the hang of the structure, they are so satisfying to solve. So this is the one we're looking at today. Question 18 from a past higher tier paper. It's a perfect example of a circle theorem proof. Our mission is to work through this together and build a flawless answer, the kind that ticks every single box in the mark scheme. By the end of this, you'll know exactly what the examiners are looking for. Okay, before we even think about writing a single thing, we need to do the most important step of all. We have to be crystal clear on what the question has given us and what our final destination actually is. Right, let's pull this question apart. So what do we know for sure? They've given us two key pieces of intel. First, A, B, and C are points on a circle with O at the center. Second, the line BA is the same length as the line BC. Simple enough. And what's our goal? We have to prove that the line OB cuts the angle ABC into two perfectly equal halves. So how in the world do we get from what we know to what we need to prove? Well, we need a plan. Just rushing in without a strategy is a recipe for losing marks. So we're going to use a really clear three-step approach. Here's our game plan. First up, we're going to spot two triangles that we can compare. You know, the secret to a lot of these geometry proofs is showing that two triangles are congruent, which is just a fancy way of saying they're identical copies. We'll do that using the side, side, side rule, which means finding three pairs of equal sides. Once we've done that, the final conclusion pretty much writes itself. All right, let's get started and build this proof piece by piece. We're going to begin with the most basic, fundamental property of any circle. Have a look at the diagram. I want you to focus on the lines OA and OC. Now, what do we call any line that connects the center of a circle to a point on its edge?
That's right, they're both radii. And the golden rule of circles is that all radii in the same circle are equal. So that's our very first statement, OA equals OC. And the reason? Radii of the same circle are equal. Using that exact phrasing is so important for getting the marks.
And boom, just like that, we've earned our first method mark, an M1, just for finding one pair of equal sides and giving a valid reason. See, we're already on the scoreboard. Okay, that's 1/3 of the puzzle solved. Now we just need to find two more pairs of equal sides to complete our set of three. And the good news is, these next two are even easier. The question literally hands us the second pair on a silver platter. It says right there that VA is equal to BC. And the third pair? Well, that just comes from looking closely. The line OB is part of triangle ABO, but it's also part of triangle CBO. It's a shared side, so of course it's equal to itself. So let's get those down in our proof. For the statement BA equals BC, the reason is simply given. Easiest mark ever. For OB equals OB, the reason is common side. Again, we're using that clear standard wording that examiners love to see. And that's our second method mark in the bag. By finding those other pairs of sides with the right reasons, we've now collected all the evidence we need to prove that these triangles are identical. Okay, it's time for the big finish. We've done all the detective work, we've gathered our three pieces of evidence. Now let's assemble them into our final conclusive proof. Let's do a quick recap. What have we got? We've got OA equals OC because they're radii. We have BA equals BC because it was given to us. And we have OB equals OB because it's common to both triangles. That's three pairs of equal sides, side, 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 SSS. We've met the condition. And that leads us to the heart of our proof. We can now confidently state that triangle ABO is congruent to triangle CBO. It is absolutely crucial to include the reason, in this case SSS, in brackets right after. And that final powerful statement, which is completely backed up by our evidence, earns us the communication mark, or C1. And that's it, a full logical proof. All three marks secured. But hang on, let's just double check we've actually answered the original question. It asked us to prove that OB bisects angle ABC. Well, what does bisect really mean? It just means to cut into two equal parts. Since we've proven our two triangles are congruent, that they're identical clones, It means all their corresponding angles must also be identical. So angle ABO must be the exact same size as angle CBO. And if those two angles are equal, then the line OB has, by definition, cut the bigger angle ABC perfectly in half. Job done.
So there you have it, a full marks answer, all built on a simple, repeatable strategy. Now that you've got this technique in your toolkit, start thinking, what comes next? This idea of congruent triangles is a super powerful key that unlocks the proofs for lots of other circle theorems. Which ones do you think you could prove using this exact method? Have a think about it, and I'll see you in the next explainer.